Hi, in this video I'm going to introduce you about the continuity correction, right? Continuity correction. So what is the meaning of continuity correction, right? So when do we need doing continuity correction? So when we convert a discrete random variable, right? A discrete random variable, or we set a discrete distribution, right? When we convert a discrete distribution, either we want to binomial, all right? Binomial distribution. Binomial distribution is a discrete discrete distribution, and Poisson that you learn now will be also a discrete distribution. So if you want to using the normal distribution, and normal distribution, right? Normal distribution is a continuous distribution, right? Continuous normal, right? For example, x will be normal distribution, normal, which is defined to be mean and variance. And normal, if x is normally distributed, means that it's normal distribution with mean and variance squared. So this means that it's a continuous random variable, right? It's a continuous random variable. So if x is binomial or Poisson, right? Either is binomial distribution. Binomial distribution is defined to be number of sample and the probability of success, and Poisson is defined to be a mean, right? There is a mean for interval, right? For an interval. So, but as long you know that binomial and Poisson is a discrete random variable, and normal distribution is a continuous random variable. So when we want to using normal distribution, as an approximation, we use the word as an approximation to binomial, or Poisson distribution, right? Or Poisson distribution. Either we're using the normal distribution as an approximation to or Poisson distribution, or another meaning here is we want to convert, we want to transform from a binomial distribution to a normal distribution. Let's say we want to transform, right? We want to do some transformation, right? Transform into a normal distribution, for example, right? So this means that we're moving from a discrete random variable into a continuous random variable, right? We're changing the distribution. This is a very big difference, right? One is discrete, one is continuous, right? The meaning here is if we want to using normal distribution as an approximation, okay, for this binomial distribution, we need to do what we call as the continuity correction. All right. Okay. Now you just listen to me explain. Maybe you don't know, right? You don't know what is actually I mean. What is the meaning here? So very easy. You just remember this. As long as you want to transform a discrete random variable into a into a continuous random variable from discrete. Okay, the summary is you want to convert a discrete distribution into continuous distribution, then we must doing continuity correction. I summarize everything what I'm talking just now. Okay, I'm talking so long. So as a discrete to continuous, we're doing continuity correction. All right. For your matriculation, okay, for matriculation now, we are trying to introduce how to moving from a binomial distribution. Binomial distribution is a discrete distribution, discrete random variable. So change to become a normal distribution with mean and variance square, right? So if we transform, if we use this as an approximation to the binomial distribution, then we need to make a CC. The CC here means that the short form for continuity correction. All right. Okay, let's see what's the meaning of continuity correction. Okay, later I will show you various examples here. Right, okay, I'm going to give you some example what is meant by continuity correction. Okay, please pay attention. So let's say if I have a probability, okay, if I want to do correction, if I want to do correction, for example, I have a probability of x equals to 15, right? X equals to 15, right? So this is a discrete random variable, right? It's a discrete random variable. So if we have an intention, to to transform the discrete random variable into a continuous random variable or a continuous distribution, or we're using the continuous distribution to approximate the discrete distribution, so we need to do some modification. Okay, now I just start how to doing this. Okay, please listen. All right, so very simple. To do continuity correction, okay, usually we will draw a rectangle, right? A rectangle. Okay, a rectangle. So for example, a box lah, okay, easy to say. So let's say there is a 15 here, the midpoint here is 15, right? 15. So the continuity correction here is, we do some adjustment, okay? We adjust adjustment of 1 over 2, right? Adjustment of 1 over 2. So means that we adjust the value, okay? We adjust the value. So look at here, what's the meaning here? We adjust this way. So it means that we're adding by 0.5, okay? Adding by 0.5, so become 15.5. And we minus with 0.5, right? To the left, we minus 0.5. So we get in 14.5. Alright, this is what we call as continuous correction. So 15, so means that equal to 15, right? Equal to 15. So it's when you do correction, your CC continuity correction. So you will rewrite this in the form of interval. This is discrete. X equals to 15 is discrete. But now I write it in the form of interval. We said it's a continuity correction. It means from 14.5 up to 15.5. Alright, 15.5. Very simple. So this is what we call as continuity correction. We just add 0.5 and minus 0.5 to the left, then that's the interval, right? Okay, never mind. If you not understand, I will show you more example. Alright, let's see the next one. Alright, now let's see how to do continuity correction for this, right? For this. So the meaning of continuity correction, if we want to do continuity correction, alright, continuity correction, how to doing continuity correction? Very simple. Draw a box. Alright, that's my method. Alright, my method. Okay, 2, right? 2. So you adding 0.5, tambah 0.5, 2.5. Tolak kosong, ke depan tambah, ke belakang tolak minus. So it's become 1.5, right? 1.5. But this is greater. Greater. No equal. Tidak ada sama dengan di sini, alright? There is only greater. So it means that the box, we don't color the box. We don't shade the box. No, we don't shade the box. Greater means this box, this is greater. To the right, kanan ialah greater, kiri ialah less than. So greater than means it's on the right of the box. We never shade the box. Why I never shade the box? Because there are no equal here. So now the correction is from 2, we are moving to probability of x greater than 2.5. This is a continuity correction. We do an adjustment of 1 over 2, alright? 2.5, alright? Okay, for example now, if I have probability of x less than 9, right? X less than 9. Okay, this is what I have already shown you. If you not understand, I give you another example. Okay, what is meant by continuity correction for this, right? Okay, look at this. We do some continuity correction for this. So very simple. You draw a box. Then you have 9. Then you have 9.5 plus 0.5 ma. Here you minus 0.5, 8.5. Do you see any equal here? There are no equal sign here. It's just less than, right? So no equal sign. We don't color the box. We don't shade the box. Alright. So we know it's less than. This is more than. This is less than, right? Less than. So now is this region less than means it's on the left of the box. Now we do some adjustment. So now it's become probability of x less than, supposed to be 9, but now no, it's on the left of the box now. It cannot include the box because no equal. So it's less than, it's on the left, it's 8.5. So this is the meaning of continuity correction. Alright? Okay, not very understand. Never mind, I go for more example. Alright, okay, let's move on. So what if I more example for you. So what if they ask you to do continuity correction, right? Continuity correction for this. So if you want to doing continuity correction, so very simple. You draw a box. Okay, draw a box. The box, you have only one value, 5, right? So you put here is 5, right? You put 5. So 5, okay, 5. So plus 0.5, 5.5, minus 0.5, 4.5. Now, okay, that's just now. If you not understand, then now should be understand, because there is an equal here now, less or equal. Just now is without the equal, tanpa equal, tak payah lorek. Now got equal, right? Got equal, so we lorek, we lorek. Okay, we shade, okay, the region because there is an equal here. So because of this is less than, right? Even though got equal, that's why I shade less than. Less than means right or left, right or left. This is must be more than, right? 5.5 and above. This is less than. So less than means this region, this region. All right, less than. So now if you look at this, right? Look at this. After you do continuity correction, right? After you do continuity correction, the 5 is no longer 5 because you see the region here. I shade from where to where? From the left up to 5.5, right? Up to 5.5. Can you see that? Up to 5.5. Up to 5.5, you know. So here should be 5.5. That's the meaning here. Okay? Okay, tak faham lagi. Hayya. So, tengok. Okay. What if they ask you to find the probability continuity correction for x greater or equal 4? Okay. How to do continuity correction for this? Very simple. Draw the box. Okay. 4. You add 0.5. Always add 0.5. The meaning here is adjustment of plus minus 0.5. So here will be 3.5, right? Perlu tak saya lorekkan? Do I need to go and shade the box here? Yes, because there is equal here. So I shade the box. Tadi tak perlu sebab tak ada equal. Sekarang ada equal, kita shade lah. Okay. 4. So 4 greater. Just now is less than to the left. Greater to the right. Right? To the right. So what is the meaning of the continuity correction here? Pause the video lah and write the answer first. So it will be x at least, right? At least. You see the area, the one that I color where? Start from where I color? Start from 3.5 I color, you know. Okay? That's the correction, right? Start from 3.5 and above, right? This one is less than 5.5, right? This is the region less than on the left. Go to the left. That's why 5.5, right? So this is the continuity correction for this case here. Okay, I go for more example. Let's see. So, all right, let's look at what is in between. What if is in between probability of x between 6 and 9, right? 6 and 9. How to doing continuity correction for this type of cases here? Same thing, all right? Same thing. So what you do is you drawing the box. Okay, you drawing the box. You drawing the box. Now you have two number, right? You have 6 and 9. So if you have 6 and 9, you draw two box lah. Okay, you draw two box. So there's two box. So okay, definitely here will be 6, right? 6. Here will be 9, right? Each of the box you go and do some adjustment. adjust sikit-sikit lah, tambah 0.5, tolak 0.5, 8.5. Ini pun adjust sikit-sikit, 6.5, tolak 5.5, right, 5.5. Okay, so ada equal tak? This is the very important. Got equal or not? No equal, no equal. So don't need to go and color, don't go and color. Okay, in between, what is in between? Mana satu kawasan in between? 1, 2, 3. Ini lebih, ini kurang, ini in between. This one, in between. Can you color the box? No, you cannot. Why? Cannot. Where got equal? No equal. Cannot. Alright. So if you do the continuity correction, it will become probability x between 8.5, right? You see the color region. You see the one that I shaded. It's from 6.5 up to 8.5. 6.5 up to 8.5. This is the continuity correction. Alright. For this case here. So now how about probability of 6? For example, I give you another example. Let's say 3 and 6 lah. 3 and 6 lah. This is just for you to understand. Okay. For you to understand. Later on, when I explain in the solving problem, make sure you already watched this video. So if less than 6, right? So if this case, what happened? Same thing also, 2 number in between. So you do the box lah. The box here, one more box. Take your time, enjoy it. Okay, 3. This will be 6. So this will be 6.5. This will be 5.5. This one is 3.5. This is 2.5. Plus minus. Okay, ada equal tak? Oh, ada. Ada equal ba. So here you shade. Ini ada equal tak? Tak ada, jangan shade. In between mean this one lah. In between mean this one lah. So now you do CC, continuity correction. So what is the result? Very simple. So you look at this color region. This the shaded region is from where to where? Dari mana sampai mana? 2.5 to 5.5. 2.5 to 5.5. Then correct. Okay, this is the continuity correction. Okay, tak cukup faham lagi, aduh. Okay, next. Alright, the last 2 example for you lah. Okay, bonus for you. So let's say if you have probability of 7 to 10. We said that 7 to 10, right? Include 7 and 10, or we can say that probability between 7 and 10 inclusively. Include. So sama juga lukis box. Right, lukis box. So kalau sudah faham, you memang faham. Kalau tak faham, you memang tak faham. So you can, this is my method. So 10. So here 10.5, 10.5 plus 0.5 minus 0.5, 9.5, right? This one plus with 0.5, 7.5 minus 0.5, 6.5. Okay, what do you think you should do? Look at the equal lah. Got equal, right? Got equal. Apa maksud equal? Equal means here that shade the box. In between. This one lah, in between. Hayo. Now color from where to where? I shade from where to where? Okay, this is what we call as CC. We do continuity correction adjustment. Okay. So probability of x between from where to where? Paling hujung sekali. Daripada yang kita start mewarna sini 6.5, right? 6.5 up to 10.5. Okay, I already do my CC, continuity correction, right? So kalau tak faham lagi, kalau saya tak letak equal, kalau saja, okay? Kalau saya tak letak equal, what should be the value here, right? If I not putting equal. If I'm not putting equal means not shade lah, right? This one I'm not shaded. Okay, tak lorek, because no equal mah, right? So from where to where? It's from 7.5 lor. Now here should be put 7.5 lah, right? Should be put 7.5. That's the difference only. Just now you have equal, that's why you start from 6.5. Alright, I think that's all for this. I have already explained to you. First, I explained why should I do continuity correction, right, in the video. Okay, so try to be attentive. Okay, the first video I talk about why I should do, right, because I want to using the continuous distribution as an approximation for discrete distribution, right? So once I doing this, I have from as x is a discrete random variable, so I need to do some continuity correction. I need to do some continuity correction before I using the approximation. That's the meaning here, right? For this video, hope you understand.